you for that. You've saved my bacon.
Thank you, thank you.
Right, I'll just go in here. I think I've got that script in here. We'll just kill that. Okay. No, that's not that one. That's the wrong one. We don't want that one at all. I think we want our presentation 2, possibly that one. Yes. Okay. So you remember we created 4 polygons, and we used those to train the classifier, and then we ran the minimal distance classifier to get our results. So what we're doing here now is just this last little piece of code we've added on the end from our trained object, which was up here in line 39. We end up, this is actually a classifier object, and one of the methods of the classifier object is to produce a confusion matrix. And you can see that comes out like this here. You can see my console there. So that's a standard confusion matrix. So what you've got here is the consumer accuracy along the rows. So along the rows is the true classes. So class 1, class 2, class 3, class 4. And along the columns are the predicted outcomes. So this is able to do this because it's using the actual polygons that we drew. So it's only it knows that everything within those polygons is supposed to be of one class, and so it's able to use that as a test. And so you can see in most cases all of the cells lie along the diagonal, which is what you would get for 100% accuracy, except in this class 2. And class 2 was the urban area, and so there are 66 out of a total of 66 plus 354 cells were actually in error. And you can understand that, I think, when you look at the urban polygon, wherever we drew it. Not quite sure where we drew it. Where do we draw our urban polygon? Anyway, doesn't really matter. When we draw a polygon around an urban area, which we did, you're obviously encompassing gardens and trees within that polygon, whereas the polygon for water was quite pure, and the same for both types of vegetation. They were fairly pure inside the polygon. But when we drew the polygon for the urban area, obviously it also includes some vegetation. So it's quite unsurprising that we actually get for this class 2, which was our urban area, 66 out of the total of sort of 420 odd to 430 pixels is in error. But you see, so when we use the accuracy method, of course, it gives us 94% accurate. Now, I think this accuracy, this overall accuracy, which is essentially totaling up all of the correct pixels, dividing by the total number of pixels, and it's a very poor way of assessing accuracy because it's very dependent on the balance of the size of each of the classes. So perhaps a better assessment is using the kappa statistic, which takes into account also the likelihood of achieving a result randomly. So kappa test is a much better test, and probably the best test of all is simply to look at the confusion matrix, and you can see basically your consumer errors along the rows, your type 2 errors, and your type 1 errors along the columns, the producer errors. Okay. When I've added that into the slide, I've also added, when we did the unsupervised classification, I've put a note in there. And you can't really test an unsupervised classifier until you have obviously put some training data in there. So the unsupervised classification as it is, there is no such thing as accuracy. It's 100% accurate in terms of what it's doing is finding clusters and assigning the likelihood of a pixel being a member of a particular cluster. So there is no such thing as membership of a hard class. There's no such thing as accuracy until you bring in the real world classes and tell it. So what we could actually do is what I'm trying to say is, I guess, that for the clusterer object, there is no such thing as a confusion matrix. There's no confusion matrix method because it doesn't have any idea of the truth. There's no training data in there, right? You could use the polygons for the supervised classification to extract values which you can put into an array, and you can then create your own confusion matrix object and then extract those values out of it if you want to. But bear in mind, I mean, at the end of an unsupervised classification, those classes aren't tied to any particular true classes until you go through and do that. So, but essentially, you can come up with the same results using the confusion matrix method, but you have to create your own. And so what you'd have to do is you'd have to put your classification results, your prediction, in one band of an image, and the truth, the ground truthing, or if you like, in another band of the same image, and you would extract those statistics together into a histogram, and which in Earth Engine speak is an Earth Engine dictionary, and you need to extract the data out of that and put it into an array to create a confusion matrix. So it's a little bit different with the unsupervised classification. Okay.
And can you hear me, Damien?
Sure, you what?
That training object it is possible to export as a TensorFlow record, right? So the trained object, not the confusion matrix, but the trained.
Yes, the trained object is a classifier.
For example,
yeah. Sorry.
We and my colleagues in the lab, they are trying to do, for example, random forests that maybe are using another arguments. But one limitation that we have is that we can explore in detail that classifier in Google Earth Engine. So if I remember correctly, you say that we can explore in detailed way that trained object if it's exported outside Google Earth Engine.
Yes.
So my question is, we can export that trained object, right, in a TensorFlow record format?
You mean the random forest object?
Yeah.
You're talking about the random forest model, so the decision tree. So effectively, the results of a random forest classification are many decision trees, or for many forests containing many decision trees within those forests. So that's a decision tree object. I mean, whenever I've done random forest, I haven't used Earth Engine. I've used R myself, so I'm not very familiar with what you get in the random forest object coming out of.
But beyond if it's random forests or neural networks or another classifier, the point is that we can export the trained object. So in this case, the object is a minimum distance classifier. So,
yes, but you've created the trained object. You're not going to. There's nothing to be gained from exporting it because you've actually created it yourself. It's the actual classification that you're actually getting information from. Your trained object is something that you have contrived yourself. It's simply a list of classes with sampled with each of your independent variables sampled, which in this case are spectral values, within each of those objects. So you're creating that. I don't know what's to be gained by taking it outside of Earth Engine, because that object in that form is only really prepared to be read by the Google Earth in the Google Earth environment. If you want to exchange sort of model data between Google Earth Engine and something else, you're talking about the trees, the decision trees.
Yeah.
So, I mean, the result here from Random Forest is a classifier. I mean, I don't know. We did try and have a look at the trained classifier here, didn't we? It was and in this case, it was a feature collection. I think from the Random Forest classifier, I don't know what that would look like. We'd have to try it to see.
Okay. Yeah.
I mean,
yeah, that was
outside of this forum, I'm quite happy to we can communicate on it, and I can help you. We can have a little look at it. Perhaps I can help you further with that. No, that's the problem. Yeah. Okay. What has anyone got any questions about that? Otherwise, I think the other thing we were going to do, I was going to have a little look at some Sentinel-1 data. I'll just override that. Yeah, we'll abandon the changes. So Sentinel-1 is a radar satellite, or a pair of radar satellites operated by the European Space Agency, and the data is provided on Earth Engine as with Sentinel-2, but it is a little bit different. The radar data is a little bit different. So you don't get unfortunately you only get the ground range data on Earth Engine. You don't get the complex, the single look complex data. So it doesn't include the phase information. But it is a little bit different because it contains as a layer, as a band, the incidence angles relating to each of the pixels. And I was just going to show you an example of what I've done here to as it's a bit of a change detection for forest fire, looking at forest fires over the Amazon. This was, which was a while ago. We were doing this last year, and one thing to consider with the Sentinel data is that no matter how much you compensate for the incidence angle, so we tend, I mean, the data comes as backscatter, but we generally change that. We do the gamma correction on that to change it to a ground range gamma value, and that compensates a little bit for the difference in incidence angles, but it doesn't compensate completely. So where you get strips of the radar data overlapping, you tend to get streaks in the values. And so what we tend to do when I'm mosaicing the Sentinel-1 data, we tend to limit the incidence angle that we're looking at. And I mean, in this case, I went from 0 to 43, and then the idea was to narrow those two incidence angles by experimentation as we go along, and basically clip the edges so that we don't have any edge effects of overlapping orbit paths. So that's one of the things to consider. I was in this instance doing a reducer, looking at the mean and the standard deviation of baseline values, and doing this coefficient of variance type operation here. So standardizing the radar values by getting the mean, taking the mean away and dividing by the standard deviation. This was just experimentation, just to look whether we could catch differences in this way, forest fires in this way. So getting the Sentinel-2 collection just the same as doing as any other collection. We're filtering it by a particular polarization as a parameter. So the Sentinel-1 data comes in various polarization configurations. It's polarized on the way out and it's polarized on the way back in. It's an active sensor. And you can choose whether to use one or all of those types of polarization parameters. And I think I set it to be to look at vertically polarized out and horizontally polarized coming in. We filter by date in exactly the same way as with other data sets and by bounds. So I'm selecting a particular polarization band, and I'm also selecting the band which gives us the angles of incidence, which is quite important for downstream calculations. Then I'm filtering it by angles in order to get that the central strip, because I don't want those overlapping areas. And then I'm doing the gamma calculation. So this ground range calculation, which is basically multiplied by pi dividing by the cosine of the angle and of the incidence angle. And it's basically accounting for the difference in intensity due to the angle of incidence of the radar signal. So it's quite a common adjustment to make. And then sorting it as we have done before. So I'll run it and see what happens. A bit of an old script, so I can't really remember how well it worked. But we'll see anyway. There's quite a lot. There were quite a lot of disturbance to see in that area. So obviously, you see it's quite a large area. I think if I change that, convert that up to and you can see that basically we weren't shy on the size of area we were looking at. But it does take a little bit of a while to get all of that out. I'm going to zoom in somewhere where it started, otherwise it'll take all day. Okay, it's quite noisy, as you see, in certain places. And so, I mean, as a tool, one of the big considerations with radar data is what we call speckle. And most people using radar data, satellite radar data, treat speckle as if it was noise, which it sort of is, but it isn't. It's not chaotic. It is a product of coherent radiation. So we've basically got coherent radiation bouncing off objects on the ground and being reflected back in different ways, and that the different reflectances adjusts the path length of that radiation. And because it's all coherent, it's exactly the same wavelength, we get constructive and destructive interference back, and that causes speckle. And so it's not noise in as much as if you knew enough information about the ground, it would be predictable, but in practical terms, you could never make that prediction. So it can be treated as noise because it's not something that we can model and get rid of that way. But there is a correlation. So I'm going to show you some other scripts now, and there is a correlation between the speckle that you'll see, the statistics of the speckle that you see in one polarization configuration with that you see in another. And so there's a team in Germany who have used that relationship and assumed a certain probability distribution of the speckle, the covariance of the speckle in those two different polarization configurations, and used that to statistically take the speckle out and to create an effective number of looks in the resultant data. Okay, so I've got I will post you a link to it, but these guys have put this in the form of a notebook. So there's a Jupyter notebook, which I will run. I just got to verify it. Copy that back in there. Okay, we've got our token. And I'll run this. So these guys, led by a fellow called Mort Canty, have produced quite a well-resolved tool here. And the idea is that you pick a polygon and you have to make it reasonably small to start with. And I click collect, and it basically collects all of the available Sentinel-1 data that this polygon falls inside. It also collects some Sentinel-2 just for a visual look. So what it's giving me there is an image of some fields you can see in that region. And then when I click the preview, it carries out the actual analysis. So what it's doing is it's at the full scale, so at the full 10-meter scale, it's correlating the time series of Sentinel-1 data for two polarization configurations. And it's assuming that their covariance matrix follows a Wishart distribution. And it's using that Wishart distribution to statistically take out the noise. So it's saying this is speckle and this is not, based on what we, what we find in the correlation of these two different polarization configurations. Okay, difficult to see how well it's performing here, but if you do the same thing, I've done the same thing over forested areas. I had a look at Borneo to look at forest clearance, for example, and that does quite a good job there. I might, it's a bit more difficult to navigate this particular maps interface. Can I go west or do I have to go east? I'll go east. So I'll put it somewhere in the center and just. But you do have to, the only limitation of it is because the calculations have to be done at the native scale. So they have to be done at the 10-meter resolution. That you have to actually, you're working with relatively small polygons each time. Oh, I need to clear all first of all. Okay. We'll try it again, and we'll see if there's been any clearance in that. So you get a bit of choice as to the type of analysis that you're looking at. Frequency will give you the number of statistical breaks in the time series. So the number of times that there has been a significant change in that pixel over the time period that you've chosen. You can choose to view the time of the last break in the model, or the first, or you can do a bitemporal one. Probably the most useful actually is a bitemporal break. So now it's telling me there's less than 2 images found, and what that normally means is I've chosen too big an area. So I'll clear that and I'll go smaller and try that. Again, it's done the same thing. I'm just going to zoom in until we get something satisfactory. No, okay. I think I just have to keep. Oops. I'll just draw another. I'll try one more time and then we'll move on, because otherwise we're going to be here all day. No, okay. So you basically have to keep going down smaller until it will find suitable images. at the moment. I mean, it's difficult to get an angle on how. Let me turn those off, possibly. Yeah, okay. To get an idea of the scale that we're looking at, I will try one more time. Just in there. No, okay, it's not going to work. All right, not to worry. But anyway, what I'm in the process of doing at the moment is looking at the underlying code and taking that and managing this operation in tiles so that we can choose a larger area and perform this operation over it. But I'll give you a link to the paper that that this is centered around, because it's quite interesting. Okay, that's what I'm going to show you for today. We should go back to the sort of primary purpose of today, and that was to look at coming back to this. So we're going to start with the tasks that we've assigned ourselves in terms of code, and we'll work through that, and then we'll try and port it over to, as we did before, to Python. So probably best if you log on, and we'll go from there. And I'll post some code to you if you feel it's too much typing as we go along. Okay.
Damien, you mentioned something about overlapping in the previous function.
Yeah.
Can you explain a little bit again?
Okay. So so I don't know how familiar you are with the way that radar data is converted to an image, but unlike visual, sort of optical and infrared and basically the shorter wavelengths, it can't be focused in the same way. So there's no analogy between the location that a radar target signal has picked up and where it lands on the sensor. So the radar has a totally different method for positioning the resultant signal. Okay, radar signal is pretty much one-dimensional, or two-dimensional if you include time. Okay, and so it locates the position of a pixel based on a few things. And primarily it's the time it takes for the signal to get back to the sensor. So the sensor knows when the signal left, knows when it came back. So it knows the range distance between the sensor and the target. But obviously there are complications there. So in theory it can work out, it knows where the surface of the Earth is. And in theory it can work out the position of the pixel based on that. But that gives it a theoretical position along one dimension. That's the cross-track dimension. And in the longitudinal dimension, it works out its position based on Doppler. So it sends out chirps of signals, and it works out the position in the azimuth direction based on the Doppler effect. Okay, but it doesn't really matter. The details of that don't really matter. But the important thing to remember is that the sort of distortions that you get with radar data are very different to what you get with optical data. Okay, and we compensate for distortion based on topography. We can also rectify the return signal. It still leaves some distortion which can't be got rid of, because those distortions themselves are based on the properties of the target, which we don't know. It's what we want to read. That's why we're looking at the radar data in the first place. We can't eradicate all of the distortion caused by the difference in incidence angle, right? So the principle of synthetic aperture radar is that it's pointing in quite a severe angle off the nadir. and that there are relative distortions across the different angles that it strikes the ground. It has to strike the target at different angles in order for us to be able to calculate the position, right? But there is a problem with that in that there is distortion caused by that difference in angle, and we can compensate for some of it, but we can't compensate for all of it. So the result is that when you look at the strip of radar data, you will invariably see a gradient of return values across the strip. Lighter, you invariably on the smaller incidence angles is lighter, and the longer incidence angles are darker, generally because you have more specular reflection away from the sensor at the higher incidence angles. Okay, and what this means is then when you put two strips, two orbit paths together, you have a very, very definite line between them. It creates a visual line between those two, because you can see that one is much lighter than the other. Whereas when you do the same with two optical images which have been acquired, you know, within a few seconds of each other, or even a day of each other, there's no reason that you necessarily need to see, if they're taken from the same angle or a similar angle under the same solar conditions, you're not going to see any barrier between them. Whereas with radar data you do, and it's not so easy to radiometrically correct those two, because when you radiometrically correct the radar data, you're basically changing the values and you're not getting back what you want, right? In the case where you want to make a mosaic, one way to improve on that is to not use the extremes of the incidence angles. So don't use the highest or the lowest incidence angles. Just take out the core from the center, and that's what I've done there. That's what I was talking about. So just trying to get rid of the edge effects, essentially. Your microphone's off. Ivan, your microphone's off. Yeah.
Yeah, sorry. I turned off because I hear it pushing the keys. Can you just very briefly show the function inside the reducer or the maximum function that do that?
Well, there's no function to do that. You have to do that yourself.
Yeah, but you mentioned, okay.
You filter it.
Yeah.
So filter angles, I created the function called filter angles, and I've just said take my image and select the angle greater than my minimum angle. I've just used the Boolean logic here. I've select greater than minimum angle and less than the maximum angle. Simple as that.
But min angle should be a parameter in that function?
With the Sentinel-1 radar data, one of the bands you get is the incidence, contains the incidence angle for every pixel.
Oh, okay. I didn't know that.
No.
Thank you.
That's all. Yeah. Okay. Are we okay to go on? We all okay to go on? Everyone? Okay.
Yes, sorry.
That's all right. Okay, so I'm going to take the tasks that we assigned ourselves at the end of the last one. So create some geometries, create a panel. This is what we were going to do to hold some widgets. We were going to populate 2 drop-down lists with some dates. We were going to create a button to activate the tasks. And then we're going to create 2 tasks, basically. One is to display a raster representing total rainfall between 2 dates, and one's to display a chart showing average rainfall across the time series for the geometries. Okay, and then we were going to put a legend on it. All right, and then we'll do something similar but not the same in Python. Okay, so I have used for my geometry, let's go and take that. I've used this. I'll put that up the top and we'll go there. So I created these 3 polygons here. So I've just chosen an area of interest and I've just chosen 3 areas basically that I know will have fairly different rainfalls, even though they're fairly close together, because they have different terrains. This is quite hilly up here. This is the centre of Melbourne, the city area, and this is out sort of west. So I've just chosen 3 areas of interest, that's all, and loaded up the silo data, okay, which I will paste in here. Let's paste here. Okay. So I don't know whether you guys are going to be. You can choose a different area or choose the same area. It's totally up to you. And see how you go. All right. Okay. So to build the panel, we're gonna put it in a function. Okay. So I'm going to say function build panel. All right. Because we're going to repeat it, where if we want to erase a chart, we can basically clear the panel and repeat this function. So I'm going to say a panel equals a UI.panel object. Okay, and the only parameters I'm going to put in there inside a dictionary, I'm going to say style, and this is a fairly common thing to write, and then another dictionary inside there, and that gives us the width, and the width comes as a string, 150 px, 150 pixels. Okay, and I'm going to create a one widget, date 1, and it's going to be just a UI select object. I'm not going to put any parameters in there for the moment because we're going to fill them programmatically. And I'm going to create another one, date 2, equals UI.select. Okay. And then we need to create a button. I'm just going to call it B1 out of it because I've got a really good imagination. Button. And then we have a few parameters to put in there. So buttons are quite simple. They just have a label, and we can put calculate total rainfall and an on-click function. All right. Now we can define a function separately, or we can just put an anonymous function straight in. And because we're not going to convert, we can't put these widgets onto the Python version later. I'm not going to be scared about putting an anonymous function in here. I'm just going to create a function. I'm going to say rainfall totals. And so this is going to be a function which calculates the rainfall, and it's going to calculate the rainfall based on the dates selected in there. So I'm just going to say cell date 1, which is an object we've created, get value. Oops, let's spell it correctly. And then the second one, cell date 2, get value. So that's my anonymous function inside my onClick. That's the argument for my onClick. Okay, so we haven't created this function yet, but that doesn't matter. You can see what basically I want it to do is to calculate the rainfalls between 2 dates, and these 2 dates are going to be the dates that are chosen in my 2 drop-down boxes. Okay. Is everyone okay with that? Is there anybody else?
Yeah, it's okay.
Okay, date list. So we're going to populate these two with the same list of dates. And the list of dates is going to come from the list of available images. Okay. And we don't have to do that. We could just say, just populate it from, just give it a list of dates, any dates. But we're gonna actually populate them programmatically, and we'll just we'll use the same function to populate each of the selection boxes. Okay. So I'm just going to, for the moment, I'm going to say get dates, just assuming that we're good enough to create a function to do that later. Okay. And then, so what we've done now is we've created the button, we've created the drop down boxes. We'll center the map on our geometry. It's called geometry. What else do we have to do within this same function? Okay. So our date list, when we create our date list, we're going to end up with an Earth Engine list, which is a server-side list.
No, thanks. No. That doesn't look like your map.
My map, no.
No, that looks like Sydney, is it? Or is it Korea?
No, Sydney.
Sydney.
This one's Melbourne.
Oh, Melbourne. You're going to Melbourne.
Okay.
Melbourne.
Melbourne. It is Melbourne. Yep. Okay. All right. So as I said, when we process this get dates function, however we decide to do it, we're going to end up with an Earth Engine list, which, as you know, we need to put to a client-side list. All right. So we know our date is called date list, and so we're going to say e.list, explicitly describe it as an Earth Engine list, date list. Okay, and then we're going to use evaluate. And then in everything we do inside evaluate, we'll create a function which deals with the client-side version of this date list. And we'll do an anonymous function. We'll be brave. Okay. And I'm just going to call the client-side version C date list to avoid confusion. Okay. And then I'm going to just create the function within the curly brackets.
But
So,
Julian,
yes.
you just mentioned, maybe I didn't catch it correctly.
Okay.
You say that when you call evaluate,
Okay.
you said something else, but I thought that evaluate will bring the function and send that to the server.
So
site.
what evaluate? Yes, it will. What evaluate will do? It will take my Earth Engine object, and we pass to evaluate. We pass it passes a client-side object into your function, and it will carry out the function in parallel with whatever you want to do afterwards. Right. So inside evaluate, we're always messing about with client-side objects. And so inside this evaluate, what I want to do, I've got a list of dates here, and I want to put them into my date selectors. Right? These are client-side objects, and I want to put my server-side object in there. So I'm using evaluate to do that, and all I'm going to do in here is populate these two objects. So I'm going to say cell date 1 equals UI.select. All right, and then we have this, we can say items, and we've already got that here. C date list is a client-side list. C date list, all right? And then we can put a placeholder in there if we want to. Placeholder, choose, or choose date 1. Right. That's cell date 1. And I'm just going to copy that because we've got another one that's exactly the same called cell date 2. Just going to copy that and paste it down there and call it, say, cell date 2. Choose date 2. Okay. So then my little function inside evaluate, all it's doing is it's feeding a client-side version of this date list into the items here. That's the main reason we're doing it here. Right. And then we'll add those two. We'll add the panel to the root so that the panel appears, it pushes the map over and appears here. We'll add the panel there, right, which we created up the top. But we haven't added these to the panel yet, so we'll do that here on the fly. Panel.add cell date 1, and then we'll also add cell date 2, and then we also add our button, which was called B1. So we've done that all on the fly. I'll put a colon down, semicolon down there, just to. So do you get what we're trying to do here? I think that's fairly clear. Okay.
I just have a question that the get datas date list equals
Yes.
get data. Where is that from? The get datas.
We haven't done it yet. We haven't.
Oh.
Written. I was hoping you're going to do that. You can do that and pass it back to me. No, we haven't done that. There's a few functions in here. Also, this rainfall totals, we haven't created it yet.
Oh, okay, okay.
So we're just assuming that we can do that later. That's what we'll do. So, I mean, what I'll do is I'll put in a couple of anonymous functions here. I'll put, or not anonymous, but empty function rainfall totals. I'm just gonna do nothing with it at the moment. And another one function get dates. Did I do an underscore? Get. Yes, I did. Get dates. I don't know whether that will. I just want to test to see if we're okay so far by building the panel. I'm going to put that up here. Build panel. I'm going to run it. Undefined. So it's giving me an error message. It's saying an invalid argument specified for EE-list, right? So EE-list is, we've used that here. And it's because my date list is null, right? Date list is get dates. So in here, I'm just going to put return 1, 2. Just to return anything. I just want to see my panel appear. There you go. So basically, I just want to see, we've done quite a lot of typing here without verifying whether we've made too many mistakes. And I just want to see whether that works. So we're going to have nothing in here apart from, well, we've got nothing in there, right? And nothing's going to happen when we click the button, but we know we've got the panel. So we're on the way somehow, right? We should actually have, interestingly, we should actually have these things appear here. So in fact, in theory, our get dates, we've returned a list. They're not really dates, but that doesn't really matter. Inside here, we're being passed a list. So that date list is passed into items. And then we should actually see those here, but we don't. So we've done something wrong. But we'll come back to it. We'll come back to it. At least the panel's right. Okay. So the couple of functions we've got to write. We've got to calculate the rainfall totals. All right. Let's do that first then. Okay. So the rainfall totals is what wants to take two dates, a from date and I'll call it a to date. Okay. Now we've got three geometries here. Actually, they are all, it's a multi-polygon geometry. And we need to separate them to create a feature collection. So I'm going to say feature collection ROIs, my ROIs feature collection. We've done this sort of thing before, right? Feature collection. I'll put the dot in the right place. Might help. Okay. So inside there, I've got to put a list of features, but I don't have a list of geometries yet. So what I'm going to do is I'm going to map through the geometries and create features from them, and then those features will be a list that gets passed into this feature collection function here. So that's the kind of plan for what we're doing here. So I'll take my geometry, which has got three geometries in it, as you remember, and one of the properties of a multi-polygon, if I can spell it right, one of the properties of a multi-polygon geometry is geometries, which, as you might guess, gives me a list of the individual geometries within it. So I've got a list here now, and I can map through that list, creating features, right? So what I'm going to get is an individual geometry. I'll just call it G, keep it simple. And I'm creating an anonymous function here, and all I'm going to say is return e.feature of my G, which is a geometry. I'm going to make sure it's a geometry. G. All right. So it's a bit of a long-winded way of doing it. If I had decided more cleverly to create individual separate features, geometries, then I could have just put them together in a list and fed them straight into the feature collection. Okay, but anyway, this is another way of doing it. We've got multi geometries. We get a list of geometries using this method here, this geometries method, and we map through the list, turning them each into a feature. And because that results in a list of features, then it is a valid argument for the feature collection. And so that gives us our feature collection. It just turns these into feature collections. Not doing a great deal there. Okay. Okay. We'll clear the map. Clear the map. Okay. So we need to get our rainfall data now. So we've got our silo. Rain equals silo. We're going to filter the dates between the chosen dates. So filter date, so from date and to date. Okay. We're going to filter the bounds to geometry. We're going to select the daily rainfall, which we've seen before when we were doing our regression. Daily rain, call it right. Daily rain. All right. Now we want to reduce it. We want to get our total rainfall. So I'm just going to say sum, which is a quick way of reducing the time series down to one total. And now it's no longer daily rain. So I'm going to rename it total rain. All right.
Sum function as a special reducer, right?
Yes, it is just a reducer. So I could say, to say the same thing, you don't have to type this. I would say reduce EE.reducer dot sum, like that. That would do the same thing. Okay, but I'm not going to do that. The other good thing I think about sum is that it leaves, I think it leaves your name intact, whereas the other reducer wouldn't. But having said that, in this case, it doesn't matter because we're renaming it anyway to total weight. So.
And well, this result will be a single pixel.
It'll be yes, it'll be a single image. It's a single image. Yeah, because it's a temporal reduction.
Oh, sum in this case is a temporal reduction.
Yes, because
Yes,
I mean,
yes, right.
the way you know that is because you're applying it to an image collection. If you apply this sum is a function of an image collection, and it reduces through the time series. If I want to do a spatial reduction, I'd have to use reduce region or reduce region.
Okay.
Yeah.
Excellent. Thank you.
No worries. Okay, so we've got our rainfall. We want to get some stats out of it. Let's say stats equals rain. And here we go, reduce regions. Here's our spatial reducer. EE.reducer. We're going to get the min and the max. It's all one reducer. We're lucky there. Okay, that's the reducer. We have to define the region. We just use geometry. And I'm going to use, I don't care how accurate it is for the moment. So I'm going to use a scale of a kilometer. Because, you know, it's reasonable for an area this size. I've chosen the whole city there pretty much in that particular one. So, is that okay?
Yep.
The reason I'm doing these stats is not just to report them, it's actually because I want to create a heat map. And in order to create a heat map, I'm going to assign colors to it. And I want to stretch those colors over the results, the values seen in the results. Okay, so that's why I'm doing that. And as you know, you can probably guess what's coming. I need to bring those client side to do that. So I'm going to use evaluate. And I'm going to put an anonymous function in there here. All right, it doesn't really matter. I'm just going to call it object. It's an object. Okay. All right. What are we going to do with it? We're going to create the visual parameters that go inside a map object. So when I talk about map, I'm talking about the actual map area. So if I look at add layer here, remember this method here, add layer. It takes one argument called visual parameters. Okay, and there are a number of items which go in these visual parameters. And one of those is the minimum, one of those is the maximum, and another is a color palette. So we're going to put all of those in there, right? So first of all, now we're being passed this object, which is a client-side version of the stats. So I'm just going to say var viz equals, and it's a dictionary. And I'll just end it semicolon just to make sure I finish up. Okay, so min, and the minimum is going to be the object. Now it's client-side JavaScript object, so I can use the point notation to get a property out. Total underscore rain, because that's what I called the layer up here. But it'll be combined with the min word. All right. And the max is going to be object dot total rain, you guessed it, max. All right. And the palette, finally. And that's a list. It's basically a list of hexadecimal colors. And I'm just going to go red, green, yellow, blue. I'm going to put, no, we'll go the other way. Blue, green, yellow, red. Blue, green, yellow, red. So I'll have blue at the, we'll take up the minimum value. The other end will be red at the other end, and then blue will go through green and yellow to get there. So just four, I'll just put 4 colors in to stretch them. That'll be, so blue is no red, no green, all blue. And then green is no blue, no. Then yellow, we have the red and the green with no blue. And then what was the last one? Red, no blue, no green. Okay, that's our palette. And that gives us our visual parameters. And there's a good reason that I've separated them here, apart from the fact that it's quite long anyway. Another reason is that I want to use this to steal a legend later on. And we're going to steal that from another script. So I'm going to use these visual parameters, put them into an argument here. Okay. So we'll map dot add layer. We want to put our rainfall there. We've already just calculated our visual parameters, so I can put them in there as a variable, and we just call it total rainfall. Right. And what I'm also going to do is add our feature collection, which is called FCROIs. And we're going to use the style method to give it some custom properties, which is a dictionary in there. And we're going to put color. Now this defines the border. I'm going to define the border, and I want that to be black. So I'm just going to say red, green, blue. Okay. And I want to be able to see through them because I want to be able to see what the rainfall is doing inside of those boxes. So what I'm going to do here is I'm going to give 8 digits. 1, 2, 3, 4, 5, 6, 7, 8. Have I got that right? Yes, I have. And so when you give, I don't know whether you're familiar with that, but when you give 8 digits in the hexadecimal format to a color, the last 2 digits represent the alpha layer, so the transparency. Okay. And so actually the opacity, so it's the inverse of the transparency, and our opacity is 0, so we'll be able to see straight through. Basically, I'm saying I don't want any color, I don't want any fill. The width of the border, I'm going to say 5 pixels. And there is another parameter called line type. And I'm going to choose dotted. All right. That's the end of that one. Now, hopefully. So where does that take me to? That takes me to the adding the map layer. That takes me to the end of the evaluation function. Oh no, it doesn't take me to the end of the map layer. That's the end of the map. Okay. Yeah, we haven't finished this add layer piece yet. So after that first bracket, we need visual parameters. We've already put those in with the style. So I'm just going to put empty curly brackets, and I'm going to call it region of interest. All right, that finishes that. I can put a semicolon there. And I think I can put a semicolon there because that's the end of the evaluation function. All right. So I think we should be good there. We've got to put a chart in there at some stage, but we won't do it right now. We'll do the getDates function. So, and then we'll start having a look and seeing what results we get. So obviously this, what I've written in there, returning that list there is nonsense for us. We want it, so I'm going to say, okay, so we'll take today's date. So I'm going to use native JavaScript to get today's date because it's the easiest way to do it. You say new date with a capital, and then I've got to wrap that in an Earth Engine object so that we can use it, the server can use it. Okay, so today is that. I'm going to take a start date 2 years before that. So let's say today. Now a function, because this is an Earth Engine object, it's quite easy to go back or forwards any number of any units. I just say today, I say advance, which implies that we're going forwards and we want to go backwards. I'm going to go backwards by 2 years, just for sake of argument. So I'm going to say -2. And then you put the unit in there, year. So we're using quite a lot of different functions here, just to demonstrate. So I've got a start date, and I've got today's date as the end. And the number of days, and I'm going to, I mean, we could type this out numerically, but I'm going to do it programmatically in case we want to change the period. So it's the difference between start date and the end date in days. Okay. So these are functions which are made available, methods are made available with the Earth Engine date object. Okay, we probably made that more complicated than we needed to. So what are we going to return? A list. What we're going to do is we're going to sequence through the days between nothing and the number of days. So we're just creating a list, a sequence. I could have done this from the very beginning. And we're going to map to that a function, and into that function we want to put in the actual date. So function, we could have done this a lot easier. What is passed to that function? Well, it's just a number in a sequential list. So I'm just going to call it NO for number. And we're going to say return the start date, advance by whatever number of days it is from that start date. Day. Okay, so it actually gives us a date, and we're going to format it because it needs to be a string. Because we want to send it to one of these boxes, we need to put it in string format. So I'm going to use the format function, which is available with every Earth Engine date. And the formats go like this, you know, year, 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 capital M's for month, month, and DD for days. Okay, we've done enough mucking about, and I fully expect there'll be a few errors in there, so I'm going to run it. Oh no, okay, good. So far so good. We've populated, at least we've populated the lists now, the drop down lists. So is anyone following this? And if, I mean, anyone following this with their own script? And if so, have you managed to get something similar happening? No?
No.
Okay.
No.
Okay. Have you been writing your own script or not?
Some of it,
No.
and it's like, it's like, oh yeah, I think I made so
Small
many mistakes.
pieces.
Okay.
No, I'm paying attention actually. No, I can follow
That's all right.
and code.
No, that's fine. What I'm going to do is I'm going to paste it in if you want it. Obviously, it doesn't really matter. You may get more out of it if you prefer just to follow along. But I'm going to paste it in anyway. I'll paste the whole lot in. Okay. Just that will get it working like that. I'm not saying it's going to work when we hit it. we might have to change it because we don't know whether it's going to work when I hit the button. I have hit the button and I don't have an error message, but I don't have anything. So we're going to have a look at why. Now, on click, rainfall total, if I change my rainfall total, we're going to find out why. This happens to me every time. Okay. Rainfall totals. If somebody's talking to me, I can't hear you.
Damien, I put on some your code, and some part I understand is you assume everything like this one.
Where what will show only one value? The sum?
Yep.
Yes.
And
For every pixel?
yeah, for every pixel, and I didn't understand the min and max.
Okay. So basically what we're trying to do here is first of all, we're starting with an image collection.
Yeah, bring data, yeah.
Okay. And then we're basically filtering it by date and filtering it by area, but that's still an image collection, right? Constrained. We're selecting one band out of it. When we do sum here, this is a temporal reducer. So it's reducing over time, right? So it's changing an image collection to an image.
Yes, like yeah.
So every pixel is the sum over time. Okay.
Over time.
And then we apply a spatial reducer, but we're keeping our image. We're keeping the image that results out of this to plot, hopefully when we get it right. But what we're doing here is we're getting the min max simply so that we can do a contrast stretch over the image.
Okay. I think I get it. What do you mean? Yeah.
Okay. What I'm going to do is I'm going to get my original one. I don't know where I've got that wrong. I'm going to cheat for a moment. and take my original function, paste it in, including the chart. And then I'm going to take off my legend because we haven't created it yet and see if that will work for us. So I'm going to choose a date, choose one date. Ah, maybe, I don't think I'd chosen the date the last time.
Thank you.
Okay, finally. All right, we've jumped a little bit now. So what I've done is I've cheated and I've pasted the chart in. So you can see here, I've chosen, again, similar to before, if I go for charts. If you have a look here, the obvious one to choose, because we want a time series, and we want to have a different series for each region, then it makes sense to choose this particular chart here, the series by region. That takes the image collection, which we've got. It takes you have to nominate the band, so we're nominating daily rain. Because this is the one before we did our sum. Okay, it's the original time series. Our regions, which we created, is our feature collection. We're using a mean reducer, so we're getting the mean within each of these polygons. I can turn that off now. My whole point in taking pains to draw out these differently is so that we can see through the middle of them and see what's going on underneath. And then my nominated scale, 5,000, well, doesn't really matter. Bearing in mind our pixel size is 5 kilometers, right? So we don't care. So I've set some options within the chart. The main title up here, and then the axis title for the y-axis and for the x-axis. And then I've set the minimum to 0 just in case we get some funky values below 0, which sometimes happens with spline surfaces and things like that. So we get a chart. The other thing we've done is basically done a contrast stretch. So all of the pain that we went through to reduce the min-max and put them in here, and I've added something here which I'll talk about, is to get this colors distributed between the minimum and maximum values. Okay, I've added a bit of Boolean logic in here, and the reason I did that is because when I was testing my original script over different areas, I found that because this surface is made up from point data, which are basically the weather stations, and some of those weather stations are a long way apart. Around the Melbourne area, it's been quite good for the last, for 100 years at least. So, but in more rural areas, in the middle of Australia, it's very sparse, the weather data. And so when you interpolate over those large areas and create a spline surface, which is what's happened to create the silo data, you sometimes get it dipping below 0. And it doesn't make sense, obviously, with rainfall. And so I have said, if it's less than 0, then give me 0. Otherwise, give me the rain. So there's a bit of Boolean logic in here. And yesterday, when we kind of looked at one of the last slides, we looked at one of the algorithms that said, one of the pieces of advice in the best practices, which said, don't use conditionals. Don't you say if this, if then else. And it said, don't even use the only recourse you have left, which is the Earth Engine algorithm, if. It says, try not even to use that. Well, this is an alternative to using Boolean logic like this. But in actual fact, you could use if statements in here because we're client side. So it doesn't matter. I could have another statement up here correcting this and using an if else loop if I wanted to, because we're client side, it'd be fine. Okay.
Can you, I guess, I'm not sure if that code is copy.
Oh, you want a copy?
Yeah, for example, I see that my min-max
Okay, I know you won't have that same thing. What I'm going to do is I'm going to give you that now.
Okay, thank you.
Dut, dut, dut. That's the function. That's the whole function. Anyway, we have one bit more fun to get through before we move on. What time is it? Hey, we'll have a break in a minute. I'll just try and get one thing done first.
I do have a small question for that, and is why, well, we are using evaluate function to and apply that to the stats object that
Yes.
I guess is the final rainfall layer. So the reason to do that is to avoid stack all the other processes and run in parallel the loading that map into the canvas.
Yes.
Right?
Yes. Yes. I mean, put it this way. When you're writing the script, you may not be fully aware at the time that you're writing a particular stage of your final script, right? And so you don't know what's coming, how much memory you're using before this or after this. I would generally, I would say that I pretty much always use evaluate to do this. So whenever you're populating one of these objects, client-side objects, I would say just use evaluate as a matter of course. And when you get used to it, it's very easy. You see, bear in mind that this stats now is a very small object. So it wouldn't make me, I could probably just say, I could say stats.getInfo, and I could run with it. I could just use the results and put them in here outside of the evaluate answer, outside the evaluate function. And it's not going to be, there's not going to be any great overhead. But bear in mind that the evaluation of this viz dictionary here will hold the whole production of this map, and so nothing would happen until this is here. The chart wouldn't start appearing until this was all done. So you'd sit here and wait for all of this map to go before you started seeing the chart appearing. So you would actually be holding the chart up if you didn't do that. I don't know whether when you run the function, you see the chart placeholder appear straight away. So you know that process has begun. Whereas if you force it to do procedures sequentially, you won't see anything happen here. It'll be blank until all of your images come up, and then you'll start to see the chart whiz around. So it is good practice, and you're not gonna hurt it by using it every time, I would say.
Okay. Okay, thank you.
All right. Okay, no worries. Well, one of the things it's a good skill to have is to cheat.
Sorry, Damien, can you copy the full script in the chat, please?
Yes, I can do that.
Please.
I will do. In fact, okay. I will do that. Yes, I'll do that during the break, because I'll grab the whole file rather than pasting the text in there. It's a bit messy. I'll put the file on there. Okay. I mean to do that with all of my scripts. So, okay. We're going to talk a little bit about theft, because there are some functionality which doesn't appear ready-made for you in Earth Engine and requires you to make them yourself. So one of these is a legend for the map area. There isn't actually any built-in methods to produce a legend, and what that means is that if you want to create a legend, you have to do it yourself. And obviously, there's two ways of doing that. If you've got a class map or a categorical map, then you need to create a bunch of boxes. You can use a panel. You always have to use the panel anyway. And you can create boxes within the panel, and you can color their background according to the colors of your map, and you can label them using label widgets. If you're using a continuous variable like we are with the rainfall, we have to use a little thumbnail image. We have to create a thumbnail image, and we have to set the parameters for the minimum and maximum colors, etc. And so there is a bit of mucking about there, and it is well worth stealing legends from other people, because they've done all the work for you. And so I'm going to do that. There's a legend in Population Explorer. So what I'm going to do is I'm going to save this. I'll save it as temp. That already exists. I'm going to save it as temp1. Probably exists too. No, it doesn't. Very important to save it before you click on another script. And I'm going to have a look for some demos. I think might be in here. No. What am I looking for? The Population Explorer interface. Interface. Why can't I see it? I'm probably staring at it. Charts, no. User interface. In here. Population Explorer, there we go. So this is a demonstration script, of which there are many, as you know, in the examples area of the scripts. And I'll just run this one. And you see it gives us quite a nice, basically quite a nice view of population densities, or population densities over the world. And we've got this nice little legend in here with obviously a continuous variable. It's fairly discrete, occupies the corner of the screen. You like that one? Not by me.
Yeah.
Good colors, right? Looks good.
Well, nice legend, yeah.
A nice legend, right? So we want it, don't we? So we'll grab it. And what I'll do is I'll sit somewhere down the bottom, and I'm just going to take 189 downwards. So
189.
189. I'm going to copy that, and I'm going to go back to my own miserable little script in here, which I called temp1. Come on then. And I'm going to go down to the bottom. I'm going to paste it in there. Okay. Right. Okay, let's look at it first of all. Obviously, we need to change it. All right, so having pasted that in there, we've got this function make legend, which creates a panel. It puts a label in the panel. Oh no, in fact, above that, have I missed one? I've missed one. I've missed the color bar.
Oh.
I'm going to save that. I'm going to go back. I'm going to grab the color bar.
Save.
Go back to my user interfaces.
Population Explorer.
Interface, and then Population Explorer. And I want to go down. I didn't click the right place. Let's go down here somewhere. Oh, I've frozen. My window's frozen.
Color.
I can't move anything.
Oh, F5 maybe?
Color bar.
No, I've frozen. I might have to reload it.
Oh, maybe so.
I'll tell you what we should do. It's 1:30. We should have a break.
Yeah.
I'm going to exit pages. I'll bring this back up. But meanwhile, if we have a break, because we haven't had one yet, and say, will 10 minutes be enough for you? What do you want to do?
Okay.
Okay, or do you want 15? What do you think? We'll just say 10 minutes.
Then it's okay.
I'll see you back here at 0:45. So we're saying 06:45. Okay? Greenwich Mean Time.
Okay.
45. Yeah. Okay.
Yeah.
I have a question, but for Mauricio.
Okay.
Mauricio, do you work with Rafael?
No, Rafael works with me.
Ah.
Rafael, which Rafael? Rafael Monge?
Yes.
Yes, somehow, yeah. But he works for the Ministry of Environmental, and I work for the National University.
But you both are together into the same proposal?
Yes, we do.
Okay, good, good. I met him because I'm trying to apply some index. So a girl from UNDP contacted us, and I thought that maybe you can know him. Oh, well, nice to meet you in any case.
Por nada, por nada. Sí, podemos hablar, lo que sea, no hay problema.
Ah, bueno, sí, en español.
Y,
Vale,
y
sí.
usted está en Estados Unidos haciendo el PhD.
Sí, sí, me dio por escribir la propuesta y la gané, imagínate. Estoy súper contento.
Ah, qué bien. Qué bien. Pero
Sí,
la ganó como Iván o como su, qué sé yo, su instituto donde está haciendo el doctorado.
pues la ganamos como la Universidad de Arizona,
Ah, ok.
pero pues la escribí yo.
Ah, qué bien.
Sí, eso, no, pues sí, estuvo, estuvo bien porque pues yo ya sabía usar un poquito la herramienta, pero la verdad no tanto, pues. O sea, tutoriales, cosas muy chiquitas, entonces esto la verdad
Ajá,
pues me abre como mucho el
sí.
ojo y el panorama. No sé ustedes, ¿ya tenían experiencia con esto?
Pues un poco de igual, copiando pero siempre se aprende y es fundamental ver cómo alguien que está con muchísima más experiencia, cómo hace las cosas, cómo eso es buenísimo para aprender uno cómo se trabaja o sea, con el ejemplo de alguien que trabaja más en esto, porque eso es importante, o sea, el tiempo que uno le dedique es fundamental.
Sí, yo no sé si tú conoces las otras, cómo estuvo la clase pasada, porque creo que este horario es tarde para ti, ¿no?
Sí, yo estoy son las 12:38. O sea, ya empezando el día recién, entonces está atravesado
12:38.
de la mañana. O sea, yo empiezo a las 11 de la noche y terminamos, bueno, a las 3 de la mañana en mi horario.
Ah, claro,
Eso es
sí.
fatal.
Yo estoy una hora, yo estoy una
Usted
horita
está,
antes. 11:38
ajá,
estoy
ok.
yo.
Sí,
Pero
porque
no sé este horario si es que es muy difícil para todos, pero somos muy poquitos. Es casi que personalizado
correcto,
este.
yo estaba sorprendido de eso, sí.
Sí, pues
Sí, increíble.
sí, porque creo que es mucha gente la que, por ejemplo, en el proyecto de ustedes, ¿cuántos son?
Uy, un montón. Es que eso es como estamos tratando de crear un sistema de monitoreo y eso es interinstitucional. Y entre toda esa gente se aplicó a esta propuesta y se ganó. Entonces, cuando mandan el correo, yo así al vuelo ya me inscribí
Ah,
y
bueno,
solo este horario
rápido.
quedaba. Sí,
Ah,
y la otra gente pensando cuál horario le quedaba, no agarraron campo. Entonces, de mi país solo yo estoy.
aunque hay otro
Sí, por
chico
lo menos,
que es Olarte, creo que es.
sí, pero no sé quién es.
Olarte, no sabemos. Yo pensé que era de Costa
No,
Rica.
no. Sí, tico, solo yo. Y parece que abrieron otra sesión porque había mucha gente y, y parece que estaba lleno ya también. Porque cuando llega el correo, ya pasó un día en algunos lados y ya se llena.
Sí,
Sí.
sabes que yo también apenas llegó el correo, cogí este horario y yo no sé cómo
Ajá.
sean los otros cursos, pero pues estoy feliz.
Sí, claro, claro, buenísimo.
Sí, pues bueno,
Vi muchas cosas que aplicar y, ay, no, buenísimo.
sí, pues bueno.
Sí. Pero Rafael lo que hace es que, bueno, él trabaja en el ministerio y pues le llegan ciertas cosas y él las baja ya al resto de integrantes de ese sistema que tratamos de crear. Eh, pero digamos es un montón de gente, hay gente más comprometida que otra, etcétera, pero es una iniciativa interesante, pero sí cuesta coordinar muchas cosas porque gente tienen sus agendas y en instituciones y diferentes visiones de las cosas, etcétera. Entonces, pero esa es la idea y él es el que coordina el sistema por mandato del ministro.
Listo.
Pero el ministro, o sea, ya eso trasciende un ministerio, entonces ahí hay algunos detalles que se tienen que ir solucionando si usted quiere de verdad un sistema de monitoreo del uso de la tierra que tiene que ver con otros ministerios.
Claro,
Pero Rafael sí es de un ministerio. Hay coordinadores de otros ministerios, pero todavía faltan muchos detalles por fusionar.
ok.
Pero en el marco de ese sistema es que se hizo esta propuesta y se ganó.
¿Y cuántos ministerios y universidades son?
Bueno, serían como 3 ministerios y universidades somos, digamos que más hemos trabajado 3.
Claro, son hartas
Sí,
instituciones.
así. No, y dentro de esos ministerios hay un montón de instituciones que son como semiautónomas.
Ya,
Entonces es complicado el asunto.
sí.
Sí,
Pues bueno, además yo creo que parte del éxito depende también de cada persona, porque como esto seguramente nadie lo tenía en su plan, ni está en su contrato, eh, mejor dicho,
correcto,
aquí
correcto.
el que más va a aprender es el que más le saque el tiempito, porque nadie tiene la obligación de
Eso,
hacerlo.
exactamente.
Sí. Pues
Correcto.
yo, pues
Sí, sí, sí.
yo me inscribí con mis profesores, pasé la propuesta. Unos me dijeron, no, pues
Ajá,
danos más cupos para mis estudiantes. Y no, pues los manes como que no, no tengo tiempo, no, no puedo, no, no. O sea, nosotros somos, en realidad yo escribí la propuesta solo. Y
así.
a mí sí, y me revisaron la propuesta dos profes. Somos 5
Ajá,
con los que me pidieron colaboración, un chico, etcétera. En total ponen unos 8 de gente que pidieron que
ajá,
metiera. De los 8 solamente 2 vamos a
así.
tomar el curso. Entonces la gente no sé si es que
Así.
no tiene como, pues no dimensiona como la utilidad o ya está, no, no sé, pero yo que
Sí,
voy a preguntar hasta el último minuto, pues.
sí, sí, sí. Buenísimo.
Sí, pues bueno, pasaré a tomar agüita. Entonces ya nos vemos en un ratico.
Sí, igual, igual. Ya
Listo.
nos vamos. Quedan
Vale.
2 minutos.
Ah,
O 1 minuto.
vale, vale. Gracias.
Okay. Sorry, just a very short break this time. I managed to find my way out of my mess, my frozen browser. So I'm just going back to the Population Explorer script that I went to originally to steal the legend, and there's a function, a block up there which I need to take as well, which is here from line sort of 172 downwards. And I'm going to steal that and put that into my own script. And right down above the script that I stole to start with, which is right here. Paste that in there. That's the color bar palette. Okay. Is everyone back from a break? Was it a little bit too short?
I'm here.
You're here. Okay.
Yeah.
Yes.
That's good.
Colombia presente.
So I've just, yeah, as I say, I've just found that gone back and grabbed that color bar function there just to start with. And we're going to see what we need to alter to suit our own needs. Okay. So this particular one literally just puts the color bar in. It accepts a palette, which is something we have to feed into it. And it, as you can see, it creates an image and that image, sorry, I should start from the beginning. So UI thumbnail is a standard method which creates a thumbnail image, all right? So what this is doing is just creating a raw image using coordinates, which are nominal coordinates because they're going to be inside a panel. Okay, so it just creates an image out of longitude and latitude, and it's selecting the first band, and that's what it's using for the image in the thumbnail. Okay, it's defining a bounding box, and these are just, this is like basically a matrix of unit values, and it's giving the dimensions of the bounding box. The format is in PNG. It's got a minimum and a maximum between 0 and 1. That's just for the legend itself. And then it's taking the palette, which is fed into the function top. So we don't need to really know. All we need to know here is really that we don't need to customize this for ourselves. Okay. Then it's got the actual function below that to make the legend. So it's creating a panel. Then it's creating a label. And the label is basically the minimum and the maximum for the colors. So they are our minima and maxima, right? So this is going to be a label one side of the color bar and the other. So here we've got a round undo color stretch. This undo color stretch is nothing to do with us. In there we can put we created visual parameters called viz. And in there, because this is the lower end of the scale bar, we can put min. So I'm just going to change that one. And then for this undo color stretch here, I'm going to put in viz. So we've got one in the at the bottom end, one in the middle, and one at the top end. You'll see these when we print it out again. So this is in the middle, so it's going to be the average. I'm going to say viz max minus viz.min. I'm going to put those in brackets and divide by 2. Okay, so I'm just getting the average between the minimum and the maximum for the middle value on the scale bar. This is all about placement, so I'm not going to touch that. And then finally, in here, under undo color stretch, I'm going to put in viz.max because it's the far end of the scale bar. We don't have to touch the flybar. That's all about placement. So here, the color bar is feeding in a palette that we don't know nothing about because that was to do with that particular script. We can put our own palette in there because we've got that contained in our visual parameters palette. Okay. And then just looking through the others, we don't need to change the style of the text at all because we were happy with that. And then at the bottom, we've got add panel now. I think that's in the wrong place. Is it not? No, it's not. Okay, so I've put in adding the panel in here. We've got population density. In fact, I don't think we need this at all. We'll create a function called legend. We'll put this in the legend function because we've got to call it further up. Function legend. I'm just going to wrap this in a function where we pass our visual parameters into it because we've used them up above. Literally just wrapping this in a function, and I'm going to, just to make it better, I'm going to move those all along a little bit. Okay, so we add the panel. The label we want to give it is not population density, it's total rainfall. Make legend, we're going to pass in our visual parameters. The next UI label is thousands of puma per square kilometre. We're just going to have millimeters. That's our units. So the legend footnote style is defined above. We haven't touched that. Okay. And we don't need anything more than that. We don't need any more labels. That's all we need to say. Just what it is and what the units are. So I'm going to delete those. And everything else is just about placement. So I'm not going to touch that either. Okay. So hopefully we haven't had to do an awful lot to it. All we've really needed to do is to put in our own visual parameters. Okay. So somewhere we have to put that in, and I think I've got it commented out here. So we're going to put our legend in there. This is part of the rainfall totals function because that's the one that produces our map. Okay, so let's see how that falls over. Okay, I'll choose a date. I'll choose one right down here. Calculate totals. We've got our chart appearing. I can't see a legend yet. It should have appeared by now. So that's not happening. All right, cheat number 2. I'm going to take my entire legend script because I've done something wrong there. I'm going to copy it. I'm going to take my entire legend script here from here downwards. Paste that in there. And then run it again. Choose date. Choose date. Calculate the rainfall. Okay. I mean, you see, another thing is that that legend did appear before the map did, and that is another reason that we're using evaluate all the time, so that these 3 things, the chart, the map, and the legend, can all happen simultaneously. Okay, so not a particularly graceful way of doing it, but it's basically about stealing a piece of code and adapting it to feed our own parameters in there. I think the mistake I made was leaving out that curly bracket. I don't think I had that curly bracket in there when I was missing a curly bracket last time. So I will pass on that entire script. I keep saying it, but I will do it. I'll do it now. Meanwhile, do you have any questions?
No, by my side.
Okay, you're gonna,
No, thanks.
I'm gonna move that over there so that I can drag this over to the chat area if it works. Sometimes it does, sometimes it doesn't. In this case, it doesn't. Well, that's good, isn't it? So what I might do is go to, I'm just going to have to email it to you because Teams never does what I want it to do when I want it to do it. So it's something to do with me working in Linux, I think. Okay. All right. So what are we going to do now? What we're going to do is something similar in Python. And I did promise you that we would pass some data into NumPy, and so that we can process it in something else like R. And so we will do that. Okay. So I mean, whether or not you've been typing along with this, that's fine. But I would encourage you to do it with the Python version. But obviously, you don't have to. I'm going to go up here and I'm going to type in Colab, probably colab.research.google.com. And I'm going to, hang on, let's just put that in there. Colab.research.google.com. And I'm going to choose a new notebook.
Mm-hmm.
And eventually I'll get one. Okay. All right. So as you remember, the three things we generally always do first: we import EE, we authenticate, and we initialize. And we spell it the American way. Okay, and then we run it. We wait for a little while. And then we wait for a little while longer. And then we get a link. And I'm going to click the link. I'm going to choose an account. I'm going to allow everything that Google wants. And I'm going to try and select that and copy it. And I'm going to paste it into my code area and hit enter. So it's given me the OK to go ahead, all clear. Okay. So what I've got here, and I will paste this to you guys, but I'll explain it to you first. So you don't need to type this. I'm going to create another cell. And it's basically a bunch of things that we're going to need to produce a chart, or to go into R, really. So I'm going to paste this to you. I'll paste it here, first of all. So it's more than we need, but I want to include all of this because it has a lot of stuff that you can then use for yourself. So what it's doing is it's bidding this RPy2 package in. I should actually uncomment that one at the bottom. And what it's also doing is it's bringing the utils to allow us to add other R packages which may not be already inherent in your Colab. Okay, so the Google's implementation of Jupyter in Colab has the RPy package in there, and the R is set up with a number of standard core packages, but it doesn't have all of them. And so I mean, we're not going to use these today, but I've just put this process in here to show you how, if you're using particular R packages, you would put them into this list here. Okay, and I've got there ggplot, hexbin, and lubridate. They're quite common packages. But there's, if you want to load those up, you put them in that list there, and it goes through and it will install this loop will install those packages into R. Okay, so we don't need most of those today, but we do need these. And so one of the things we'll do, and I'll post all of that to you now.
Thank you.
You're welcome. De nada. I'll run that and see what happens. So it should come up with a lot of spiel down below.
What made the % symbol at the line 28?
This is a magic quote. They're called magic quotes, and they and magic is the term used when you're running external packages within the IPython environment. Okay, so this load extent is actually running, I think, a bash script to run this IPython too. I'm not quite sure. It's required to actually load the IPython, the rpy2 IPython package. Okay, because these are all basically raw Python packages, but this particular one is an IPython package.
I see.
So it's a special magic term used by IPython. There are others, right? And I'll show you what I mean by that. First of all, I'll just show you that you should get something like this. When the load has finished, you'll be able to just get rid of that. Okay. But while you're doing that, I'll just add a little box below myself and just show you that if I type in a percentage sign, I get a list of magic functions. And these are functions which I can perform outside of the Python environment. And you can see I've got latex there. I don't know if you use LaTeX, JavaScript. I can even type in JavaScript. If we miss it so much, I can start typing in JavaScript and HTML, things like that. So I can do all that here. Quite often people use the HTML one just to have a quick look at an image file, for example. You could literally just say HTML, right? And I could just start typing tags, image source equals, and then I could put the file name in there, and then finish the tag, and I'd run it, and it would show on a web page just below here. Probably I don't know what it'll do now. Yeah, it's got an error because it's not found anything. But again, all of these magic functions, they have an equivalent with 2 percentage signs, and that gives you an absolute code block, right? And that will, as I promised you yesterday, if we do this with R, for example, single R, 2 percentages and R. Now I've got R completely, right? It's empty. Yes, I know that. I haven't typed anything yet. So what I say is, what can I show you? So let's just ask $plot, for example, and it's just giving me the R help manual for the plot function. Okay, so it is raw R. This is really R. You don't. It's the bona fide, I think, real thing. So I'll empty that first of all because we're not ready to use it yet. And I knew you'd like that. Okay, we're going to do some of the boring stuff, but we're not going to do a lot here. I promise. I'm just going to paste this to you, right? So this first one, I'm going to take our data. So you don't type it. I'm going to take our silo data up here, just as we did in JavaScript. This is our multi-part polygon. And then this is our feature collections, right? And we've built them in the same way as we did in JavaScript. except instead of using an anonymous function, we've had to use a lambda, but we've done it in exactly the same way. We've got our geometry, we've called the geometries method to split them up, and we've mapped this little function here, which returns a feature for each one. So exactly the same thing as we did, right? And I'll give you that. Shall I give you that, or shall I give you everything in one chunk? We'll see anyway. That. Okay, that's that. I'm just going to run it to make sure there's no problems, and nothing happens because we haven't told it to do anything. Okay. Right. Then okay, here's where the fun begins. Just gonna. Okay. So similar to what we were doing before, in this little exercise, I'm doing something slightly different. I basically want to do a simple time series plot for those 3 regions. Okay. So what I'm doing here, I'm doing it slightly different way. And that's because I'm aiming to get everything out in a distilled way. We're not using a chart object. That chart object accepts the raw, the image collection and the reducer, etc., etc. We can't use any of that because we're not using a chart object. So we want to do all those reductions ourselves. Okay. So I'm filtering the silo collection between those dates. I'm selecting the band we want. Actually, that 2 bands. Yes. So now what I'm doing, this 2 bands method is actually a reducer. It's reducing the image collection to a single image, right? With 1 band per image. So it's taking all the bands I've chosen in the image collection, and it's reducing it to a single image with lots of bands. Okay. And every band we're then reducing. So we're reducing that image using our feature collection, where we're saying we're nominating the mean reducer, and we're using our 5 kilometer grid scale. Okay. And then now, yep.
Okay. Now the question was, as we are converting every single image in our image collection into a single image with several bands, we need that every single image only contains a single band as well. That's why are you selecting the daily rain?
Yeah.
But it could happen that maybe supposedly we have in every single image in our image collection 2 bands, let's say.
Yep.
And convert them to bands.
Yep.
What that
What
will be
would
an
you do?
error?
No. You just have to manage it differently. And this is a great adventure that you're on, Ivan. And what we'll do, because you're challenging me, I will put in another band and we'll see what happens. Okay. But it's a good question. It's a very good question. And no, I mean, it doesn't fall over. What happens is you're just adding another dimension to your array, and you just have to manage it. So what this process is in going from the JavaScript sort of functionality into this area where you can then process it with a NumPy array is a bit of trial and error to see the shape of the data you get out of it and what you can do with it. So I'm calling up one area here, sorry, one band here for that reason, as you say, right? Mm-hmm. If I had 2 bands in there, and then making this into 2 bands would maybe a little bit problematic, because it would just add them all together, I believe. But that's okay, you can still do it, because you would do it in a different way. What you might do is you might collapse these bands into an array, into an array of size 2. So you have 2 values instead of 1, and then do exactly the same as we're doing now. And at the end of it, you'll get results, but you'll have an extra dimension which you have to accommodate in your processing. Okay.
Okay, okay, good.
I'm just going to go to that 2 bands because what's a good question is this is a function we're using, converts collection to single multi-band image containing all of the bands of every image collection image. Output bands are named by prefixing the existing band names with the image ID from which it came. Okay, so you'd end up with image 1, band 1, image 1, band 2.
Yeah, like a collapsing all in a single train, but
Exactly, and I wouldn't do it that way. I wouldn't do it that way in that case.
no.
I would convert it into an array first, and then do it. Yeah. So we'll carry on with this first of all. Let's get one that works, and then we'll break it afterwards. Okay.
Okay.
Okay. Now, one of the things we're forced to do here. So we've got our data there. That's got everything we need in there, right? Because it's got our regions. It's got our whole time series. So we're going to use get info, right? I'm going to call it local, right? That what we're going to produce is data.getInfo because we can't use evaluate in Python. I'm just going to run that. All right. So if I put a code sample there.
So what do you say? Sorry about the evaluate in Python.
It's not available to you.
Oh, okay.
Okay, it's not available to you. So we use get info. Anyway, it's not relevant in the Python environment. You really have to work with all of the data at client side to start with anyway, right? So you have to use get info, and then we have to have a look at it. If I just type local, you can see now we've got a dictionary, right? So this is a dictionary. We've got pairs, key value pairs. The key, as you can see, is made up of a year and a Julian date. So it's converted the date over to a Julian form, and it's put daily rain there. Okay, and then we've got our values next to it. So we've got a lot of zeros, but a lot of values. So that's our rainfall values. Okay. All right. This is our daily rain. So we've got an awful lot of these, right? But we're only looking at a year in this case. We can expand it out later, see how big it gets. So that's our local. So we want to do something with that local data. We want to do something with this. I mean, this is okay. Our values are okay, but we want to turn this into a recognizable date. Okay. So we need to map, as we would do in JavaScript. We're also going to do that in Python. We're going to map a function over here, and we need to create a function which processes this date into a recognizable format. I'm going to put that in here. So I've created a lambda so that it'll go on one line. So lambda just takes, you put the argument here and you put the return straight out, as you probably know. So using two things, using this the string p time and string f time. So this one is recognizing the input format that I'm telling it to recognize. So this is just a format version of the format that we're receiving the data in here. We're getting the year underscore Julian date underscore daily rain. So I'm telling it that's what to expect, right? That converts using the date time. Oh, have I loaded date time? I think I have. Sorry, just a moment. Maybe I haven't. I might have to import date time first of all. Okay, anyway, we'll soon see if there's an error. So date time there. So this produces a date, and then this function here reformats that date into another string which we can recognize, and but basically it's which I'm only concerned with what R will recognize. So this is a date that R will recognize. Okay, so that's why we've created that lambda. All right, I'm going to post this to you in a minute, I promise. So I don't make all these promises, and then if you forget, you don't get it. Okay, no. I'm going to give you the function now. Below here. So this is. So we need, but basically, all this is doing is we had a look at the local that we got, and we want to put it in a format that we can feed it into R in, and basically, in order to feed it into R, we have to give it a NumPy array. Okay, so I create this function get series. Okay, and it's taking our dates. So our local data, which is this here, and it's sorting it, and it's if we look at the structure of the local data, we have features, and then we have our index, which is what I'm calling, because we've got 3 sets of features, right? So I'm calling up the index in each case, and I'm getting the properties out of it, and I'm extracting the keys. I probably haven't explained why I'm doing this very well, so I'll go to the top of this, or somewhere around it. Okay, what this is basically a list of coming from a feature collection. Let's go right up to the top.
Are you printing process dates, or
Yeah,
which
just
object is that?
Just wait a moment and I'll show you. So, you know, I called this when I typed local, this is what we got out.
Oh, local.
And our data, remember, going right back, when we use this reduced regions, the result is a feature collection. And the properties we want are the properties, the attributes in the feature collection, okay? So we've taken, so what this is a client-side version of a feature collection dictionary, right? And these are the columns. So there are features, and in the features, there are 3 features in each case, and for the features has properties, and the properties, each of the properties has a key and a value. So we're extracting the dates into the from the keys. The dates are here, and the values from the values of the this is just a definition, so the values are actually down here. All right, here we go. Look. This is the shape. These are the properties here. This is where they start. And so what I want to do is I want to map. Here I've imported datetime. That's why I've done it. I want to map to my my dates. I want to map this function that I processed here up here to each of those dates. So this is the mapping, the way you map in Python, right? You just call it's a native Python function map, and you put in the function that you want to map in, and you put in the list that you want to map through, which is this list of funny dates, and I'm applying this process, this lambda here, to it, and that gives me J. I'm forcing it into a list, and I'm sorting it. All right, and then we've got our values output. We don't have to do all that to values because that's how they come. We're happy with them as they are. So the next thing it does is then it puts them into a NumPy array, each of those. It puts the dates into one NumPy array, the values into another NumPy array, and it returns them. Okay. What I'll do is, while you're thinking about that, I'll copy this and paste it to you. This one here, first of all. That one there, and then this one here.
Yep.
Copy. Paste. All right. All right. So, are you happy with that so far?
Yep.
Yes.
Okay.
I do.
I mean, and so really to get to this stage, and I did this this morning, and to get to this stage, I didn't just type it out like this. I basically got to here, and I had a look at local, at the structure of local, and well, what do you get? Well, it's got features. So I had a look at the first feature by typing in 0 here, and then it's got a load of properties. So that's what led me to put this key in here, and I had a look at the properties, and the result of that was essentially a dictionary of key value pairs. And so that's how I got to this stage. I say, okay, well, I want the keys out as dates and I want the values out as values. And then the dates being in that peculiar format, we have to create this little function to change the dates into a format that R will recognize, and then we push it into a NumPy array. So we end up with 2 vectors at the outside of it. Okay. So here, I'm just going to, I don't want to call it, well, it doesn't matter, because we're going to put it into I'm going to say map get series. That's our function.
Local.
I'm just going to say for a moment, I'm just going to say, I'm just going to put in a tuple. To see what happens. So I'm going to apply that over our 3 indices. So what I'm doing here is, so this IND represents an index because we have 3 geometries. So I want to do this once for each geometry. I'm putting my 3 geometries there. If we wanted to make it more, what I should really do is I should basically query. I should really just query the number of features in local to make it more general, so you can use it for other regions. And then that will obviously be 3, and then I would use that to populate this. I'm just going to run that. No, there's an error. Okay. That's because I haven't.
Oh, you have to run the previous cell?
Oh no, get series is not defined. Yes, it is. I'm just defining it up here. I have to run that. You're quite right. I thought I had. Okay, that's all right. So if I type in stuff, okay, it's not a list yet. So what I'm going to do is I'm going to force that into being a list. I'm going to say stuff equals list. Run it. No, why not? Date time's not defined yet. Okay, you know what I need to do? I just need to go to my function and take this thing out. It shouldn't be there. It should be up here somewhere. I'll just put it up here. Run that, and then run that. Okay, now I can say stuff, just to have a look at it. Okay, that's looking better. So you can see I've got a series of arrays. And we know that there are 3 sets. Okay, I can see them there. And they alternate between the keys and the values. So the dates and the values, and the dates are recognizable. Okay, so I'm going to change that to number equals the length of stuff. Now we know this should be 3. I'm just going to make absolutely sure. Yeah, okay. So if we're doing this properly for long-term use and for other use, more flexibly, rather than putting this 0, 1, 2 in here, I would create this list programmatically by querying how many objects we've got. We know we've got 3, so we can do it like this. So you might do it differently in the future, right? So we want what we want to do to throw this into R. The best way to have this is to have our dates and our values separate, right? And so I'm going to say dates is NumPy array, and then I'm going to say a. So it's basically two. We've got two indices. We've got the first one being the dates, and the second one being the values. So A for A in stuff. Right. And I'm going to do the same thing for the values. I'm just going to copy that, paste it, and say values. Oh, it's rain actually, isn't it? It's rainfall. Equals A1 for A in stuff. I'm just going to have a look to check that. So I'm going to say dates and run that. Okay, so dates is a bunch of dates. And rain is a bunch of rain figures. It's two-dimensional. You can see it's got two sets of square brackets here. We'll just have a look at rain. Should that be? Yeah. So we've got one rain there, one set of rain there for our first object, one set of rain for our second object, and another set for our third object. All right. So it's all in there as it should be, I think. And the same for dates. I'm just going to check one of them. So we've got individual arrays for each of the regions. Okay. Do you want me to paste that to you?
Please.
Okay. Stuff, probably not the best name, but there you go. Okay. All right. So we've got our dates and we've got our rain. What do we want to do next? Well, here's where the fun begins. Because we can just, yeah, we're going to go for R. Right. So what happens is, so you've got two ways of using these magic functions. If I want to do a single R function on its own, I can just type in R, and then I can write some code here. There are, as you can see in this box, it tells you there are sort of various options to use. You want to put an input coming from NumPy arrays and an output if your R code is going to produce an output. But then whatever function you type after that is R, but it can only be pretty much on one line, right? So we want to put in a whole code block here. So once I go like that, as I said to you before, it's all very exciting because that's now in R. We can now type completely in R, right? So if I say as dates, right? And I say head D. Okay, it doesn't like it. Well, no. Okay, one very important thing. You've got to import your NumPy arrays. So you use the I option, dates and rain. Okay. I also bring that number in because actually we need to manipulate matrices, and I'll tell you why in a second. Now that W is a width. If we want to plot anything, I just want to tell it, don't make it too small, make it 1,000 pixels wide. And then I'll run that now. Okay. So there's the head of our dates section. So the reason I want to bring this num in, we know it's 3, right? But we're bringing it programmatically. Is that when you do bring it into R, it flattens the arrays again. So I mean, it flattens the NumPy arrays. So here you see, we know we've got an array which has got 3. It's got 2 dimensions, right? it's got 3 lists of dates, and this has got 3 lists of rain. Unfortunately, when we bring it into R, it flattens them, right? So we need to know the shape of our, we would turn it into a matrix, and we need to know the shape of that matrix, and we can only know that by knowing the number of dimensions we have, or not the number of dimensions, I mean the size of the second dimension, I should say. Okay. Okay. So we don't need that head now. I'm just going to say, so I'm going to change D to a matrix of dates, because we want these series separate, don't we? Right? Number of calls equals number, right? Number of columns equals number, and I'm going to say by row. I'm going to feed it in by row. Okay, and I'm going to do the same thing with the rainfall. Just going to copy that. Same thing with the rainfall. Rain equals matrix. Go away. Rain. Exactly the same. Okay. And then I'll just have a look at one of those just to make sure it's all going to plan. Okay, so there's our matrix. And I'll do the same with dates. So there's our dates. And as you can see, as you'd expect, they're pretty similar, right? They're the same. Now, I could have thought about this earlier and said, well, I only need 1 set of dates, and I could have made my life easier for myself. Doesn't matter. All right. Okay, so what do you want to do with it? We've got the data now. We can plot. Plot. Now I need to as date D. Now I'll just do the first column is my X, right? And then also the first column of R. 1.
Maybe
I'm
type,
not.
Maybe type equals B or L.
Oops. I would say N. Do you know why?
An empty plot.
Yeah.
There's a E missing.
No, it doesn't
Type.
matter. Doesn't matter. No, the reason I want to do an empty plot is because I want to plot all 3 series on the same plot. So I'm gonna. There's method in my madness, I promise, right? So I'm gonna use this empty plot to make it the right size. I'm gonna define the X limits. As date D, and the Y limits.
Range D. Range R. Sorry.
Yeah, Y lim equals range R, as you said.
Yep. I guess you are. You need to close parentheses when you define as date.
Oh my word, that would go all over the place. Yeah,
And there's a E missing in type.
that's okay.
Oh, really?
Yeah, yeah.
Oh, well, believe you.
I've got too many. I think I've got too many left at the moment. Okay. What else? What do you want to put on there?
Title.
I always do this because I don't like the box. Yeah, titles. Then, well, I'll call the X. The X label is date. The Y label is the rainfall. Millimeters. Okay. let's see, first of all, if that falls over or not. Yes, it does. Length of X and Y differ. Why? Why would that be?
Yes, let me see.
That's 3 in each case.
Oh, you need the first argument of D, the first column of D, or second or
Oh,
third
here,
column?
you're
Only
right.
one column.
I put 1 there. That's right, that's what it should be. Ah, well spotted. Okay, so that's what happens generally, right? So there's my empty plot. I've only done that because what I want to do is I want to iterate through the objects 1, 2, 3. I don't want to have to write each line out one by one to plot them. So I'm being a bit lazy, I guess. So I'm just going to use lines, or say for I in sequence 1 to number, whatever number our number is. We know that's 3, but it doesn't really matter. Okay. And then I'm just going to use lines. And then we can do them, again, something similar as date D, and then I this time. Yeah, that's date. R. I. And then I'm just going to say the color equals I. We could do the line type as well, but I'll just do the color. Okay. So that's. Well, hey!
Voila.
We finally got there. All right. Okay. So legend in the top right, for example. Legend equals, and what are they? Just numbers, aren't they? Paste. I'll call it region space I. Oh no, I've got
No, 1, 2, 3, or
yeah. I'm trying to be good, right? By
Yeah.
being general.
yeah, good.
Okay, and then the color
Call.
is the same.
Yep.
I should have defined it above, so I didn't have to keep retyping the same thing. And the
Line type.
Are we done?
Yep.
Well, hey, okay. I mean, I won't bother going further. You can see basically you can do anything. From here on, you're in R, and that's another world, right? So we've kind of gone the same way. So you can pretty much, as you see, with R, you can do all this. You can do the same with Matplot. And as you saw up here, you can load up any R packages you like and work with those. And that's for charts and plots and things like that. There are also hundreds and hundreds of other, most of the visual packages, any visual package that you can use in Python, you can bring in and use in exactly the same way. And I think most of them you can implement with these magic functions. And we saw also that you can mimic the map area of the JavaScript IDE using eFolium on Colab. But if you go with a local Jupyter notebook, and the only reason I haven't done that here is so that we can all share this experience together we don't have to install anything to do it. But if you do your local one, you basically just have to install Jupyter and Earth Engine, the Earth Engine Python API. It's very easy. And then you can do all this on a local Jupyter notebook in exactly the same way. But the difference is you can use the IP widgets version of the map, and that gives you a totally interactive map that you had this similarly to the way you had with the IDE basically. But what I'm trying to say is you can do anything you can do here with the JavaScript IDE plus a lot more. So I think it's a good option.
Definitely.
All right. The other thing I could do is I could
Just before we go next, I just have an error on the function get series.
Yep.
I just copy your code and I just have a like error dots equal sorted.
Doesn't like it.
Yeah, like I don't know why. I
Is
was
that from this block here, this cell here?
yeah, that one. Yeah, just like showing error like this.
Indentation problem.
Oh yeah, okay. Yeah, maybe an indentation looks like an indentation error. So you just have to make sure that these are all indented the same way underneath function definition.
Okay.
I'll let you do that and see if it works.
Yeah, I think work. Yeah, but I need to get the R code to do it to check.
Ah, yeah. Okay.
Yeah.
Do you want me to paste that into you?
Oh yes, please.
Is that? And then we'll break it. So let me know if that works, and then we'll.
Yep. Cool.
So really, the key to all of this, and none of this is particularly clever. The key to it all is this cell here, this little cell here, because that is the work you're doing, distilling everything in Earth Engine. In fact, this is all that Earth Engine's doing, right? These couple of lines. And it's what you get out of this that determines what you do next. And so all of this is really just trying to manipulate the downloaded, if you like, data into a format that you can put into NumPy arrays. And you can see there's a couple of things I probably could have done better. For example, it turns out, the dates are all going to be the same. I didn't need to, but that's fine. I mean, the way that I processed the dates here, that was purely because I observed in the data that we got out the Julian dates as part of the key value. And that might not always be the case. So in some instances, what you might want to do, and what I've done in other projects, is I have taken the date, which in the image, the date is a numerical value. It's a long integer representing milliseconds since Unix time, right? So you can put that into an array with the values of interest and bring those back as well, and use that to pump out the results into eventually you've got to reprocess the dates to get them back out into recognizable dates again. So that's one of the other things to do. If you want, for example, now what's the other band called? I think it's called Max Temp, isn't it? If I say here, let's just create another cell. The great thing about this as well is we've still got our data all loaded. So I can say silo dot aggregate array. And no, I don't want the actual, I just want property names. Okay, dot get info. Oh, come on, don't be mean. Okay, what I'll do is I'll turn it into a list, e.list. Make sure it's a list. Oh, come on. What's it doing? Okay, okay, let's go silo first. I'll take the first one. No, it doesn't like it.
But maybe the first one, only plot the first one out to see what happened.
I'd say, yeah, actually, what I want is silo first. I want band names, don't I? Band names, is that how it goes? Okay. Will it give it to me like that? You see, it's a lot of messing about. What about get info? Okay, finally. Right.
Got it.
So these are the band names in our silo. So let's go along and select max temp as we used before, because we know it's okay. And I'll even put it in quotes to make it right. Okay. So then we can do that and we'll have a look at it. And this breaks our script, by the way. So then in here, we'll have a look at local. Okay. So what do we get? We get pairs of key pair values. We get the date, the value, and then the next date and the value of the other band. So we would have to manage this in some way, programmatically in Python. Now you could either do it like that, or you could get it out in a different way, right? You might not go to bands here first of all. You might say, what happens if you say to array? I think that's the function. We'll check in a minute if this doesn't work. Okay, why is that? That's because we've now got, no. We want to turn it into an image array. We don't want to turn the image collection into a single array. So I want, first of all, I want to turn each image individually into an array. I think it's just the same function. To array, yes it is. To array, you nominate the axis. But what I'm doing is I'm applying it to the silo. So what I need to do, I could possibly reduce the regions first. But again, it's going to keep those together. So you see what I might want to do. What I would do is I do want to turn that into an array. But in order to do that, I have to use a mapping function. And in that mapping function, I would say to array. So it turns, instead of having a 2-band image, I have a single band image with an array of 2 values. And then everything else can be the same. These bits can be the same, except that when I look down here, I would have 2 values in square brackets here. Yeah. We probably would not retain this title anymore, so we would have to also feed the date into the individual image, and you do that just by in the same mapping function. Yeah, exactly. You set. So in the same mapping function, you set a value, call it date or whatever you like, into back into the image. Yeah, I'm not going to do that now.
Yeah. That's the long way. The short way is repeat the same cell with the other single band name, right? For example,
you could do that for sure. Yeah, you could do that for sure. It's another way of doing it. Yeah, but you get used to not thinking like that in Earth Engine because it involves a loop. So you get used to trying to do everything in one hit. And I would definitely start here. I would start there, and I think I would do, as I said, I think I would take it. The other one to use is quite useful is the reducer to list. So for example, I could, once I've got my image collection set up, in fact, you know what? You see how we've gone here 2 bands. Well, this is our image collection as we like it here. If I say, what about if I say reduce? Let's just go mad. Reduce EU.reducer.toList. So that puts, I might not like it because I'm getting two values, but we'll see what that looks like. I'll see if that works. It might not work as it is in that form. No, of course not. That'd be too easy. But I might stop it there. You might not like this. Might be too much data. Don't know. No, doesn't like it. I think the reason is I really have to turn this into an array. I don't think there's anything I can do about that. When I'm dealing with these two, if I don't put it into an array, they're just going to end up concatenated together, as we saw before, and then you have to re-separate them again. But that might not be a problem. But you know, I mean, if I, is that how we had it? Yeah, how we had it like this. This isn't that problematic because you remember when we went into R, we this event here, bringing in the NumPy arrays into R, as I said to you, it flattens them anyway, right? So then you need to know the shape of those matrices in order to put them back into the right shape. This is what we did here. And if you know that, you can just do it from there. You could almost go from that stage. Where is it? Yeah, you could almost go from that stage here to this stage, almost, or maybe to here, to put them into an array as they are, and then feed it into R and sort it out in R. It might be easier to sort it out in R. You see, I'm not that great a Python aficionado, so if you're better at programming Python than I am, which is quite possible, you know, I might sort this out in R as a different choice. I better put my earphones on because I can't hear you because the kettle's on.
Yes, I'm trying actually to get the local object inside R directly, but I'm trying. I'm just trying.
I think using this method that I've used here, using this, I think it has to be a NumPy array.
Yeah. Oh, I see. I see.
By the way, I should say also that, you know, as you would in R, when you do this plot, you can set, you can do as you would with PNG, or rather than plotting to the screen, you can also plot to file in exactly the same way as you would do in R.
And where will be located? Maybe, in our Google Drive account, I guess.
It will be in your local drive here. It will fall here.
Oh, I didn't see that. Oh.
No, you just click this. This is now bear in mind, this is a temporary virtual box. And so it's not connected automatically to Google Drive, but just clicking this button here will mount Google Drive. It makes it very easy. You just click it, connect to Google Drive, choose an account. Right. I'm going to say run this cell to mount Google Drive. We're going to run it. Go to this URL. You've got to sell your grandmother again. She's pretty desirable. Okay, copy that. And enter your code. Come on. Okay, it's mounted. We're all happy. I can get rid of all that now. And where will I find it? We ask ourselves. Oh, no, I know where it is. Go back, go back, go back. Content.
Content.
It's in here, Drive. Yeah. Once you've come out here, by the way, you can't go back. It's always, you get to see all of the folders within your temporary box, none of which are obviously available to you. But so yeah, there's your Google Drive. And you can just use it in exactly the right way, the same way. So you can just put your PNG here, just put a file name in there, and put, as you normally would with R, and put it straight to your drive as a local, or you can use relative file names. You might be able to use absolute ones, but you'd have to go through all of this. Are we okay?
Yes.
Yes.
Super okay.
Super okay. So I want to send you some files, but every time I try and throw them into this area, it doesn't work. So I am going to ask Yvonne to email them to you.
Okay.
Okay, you'll have to trust me. I'll do that. And you'll also get the recording, obviously. I'm probably going to call it, open it to questions now, really. I think I've gone as far as I can go, and let you, if you've got anything you want to ask about specifically, please do. That's good.
Okay, I have a question.
Oh,
If I can. Yes, because running on this Colab, you are calling the Earth Engine libraries and the data from Earth Engine.
yes.
You mentioned that all of this can be run locally, but I understand that this can be harder to get the data from E, or is it just a matter of transfer?
No, no, it's exactly, you run it in exactly the same way. You barely notice the difference, really. So look, maybe I should go through that process with you. I can just to show you. I mean, because I've got it on here. So I just go into a terminal, and I've got a Conda environment set up called Earth Engine. So I would say Conda activate. Conda activate, and it's just called EE. So there it is. Okay. And then I would
Using
say,
R.
sorry? Jupyter Notebook. Just do that. And then I'll wait for a little while. Hopefully not for too long. Okay. I'm already using that port. That's fine. So, okay. Now,
I have one more.
so here I'm going into this is my own area. I'm going to choose a new Python 3 notebook. Okay, so this is all local, right? It's my local drive. I'm just going to say import EE, EE.authenticate, and capital, I think. Initially. It's going to be spelling things badly. Oh, and it takes me straight there, a little bit quicker because it's all local. I'm going to say yes, you can have all of that. I'm going to copy that. I'm going to go back. I'm going to paste it in there. And that's that. Okay, so and on we go, right? So now just to prove, I'm going to double click that. I'm going to create a cell below. And I'm going to say lol equals ee.image not hello. And it's an image, it's quite happy with that. So basically, if the quickest way for me to show you will be if I, for example, take the silo data. I'll just take this cell, okay? And I'll just copy that in there and run it. Okay, it doesn't have to do anything, so there's nothing happened. So I'll just say FCROIs dot get info. Okay, see, there you are. It's quite happy. It's got a feature collection. There's its geometries, and these are its properties. It doesn't have any properties, but that's fine. So yeah, and it's got the silo data. If I say silo dot first data first, which is a function dot band names. That's a list. Dot get info. There you go. So exactly the same as before. So it's quite quick. You don't really notice much difference, I would say. Sometimes it seems a bit quicker, in fact. And this is all local, so.
Okay, so the data is imported as you create the image collection, or is it just a link to this?
It's not imported, is it? I mean,
Okay.
bear in mind that when we're using Colab and when we're using the JavaScript IDE, we're using a front end locally, aren't we? And we're doing most of our work on the server side, and nothing's different here. We're doing most of our work server side. So these functions are calling, this is all being done at Google. And it's only when we want to see the results of some data, that's the only thing that's downloaded. So the only thing that's been downloaded here is a list of strings. That's the only thing that's appeared on my screen. None of this data, this silo is nowhere near here, right?
Okay.
Yeah. So there's not a lot of difference, really. It's just that here, and all of this that we did on the Colab, so this, if I run this on my local machine, it'll tell me, you've got this already, don't be stupid. Because I've run that before on my machine. So I don't have to do that again. I mean, I have to use these import statements, but I certainly wouldn't have to reinstall R packages, for example, because I've got all of those. Yeah.
Okay, I just wanted to convince that this is, in fact, the external function.
Yes.
Mm.
Yeah, you're using in exactly the
just
same way.
references and yeah.
Yeah.
Okay.
So you still have the same issues. When I use get info here, obviously if I do that on Colab, I'm forcing Earth Engine to send the data to Google, to another Google repository, right? Whereas here I'm forcing it to send it to me. And so that depends on my own internet capabilities. If that's a massive object, then the pipeline is it goes in a different direction, doesn't it? But I haven't noticed really any fundamental difference in performance using local. If anything, I would say it's a bit quicker doing it this way. Bear in mind that you can implement these notebooks in JavaScript if you wanted to. I've got one running for Bash scripts because I use GraphGIS quite a lot, and so I run my GraphGIS scripts in Jupyter Notebooks now, and it's great. And you can.
Oh, really?
Yeah, I love it.
Okay, good.
Yeah. So.
I, for example, I use Grass a lot.
Oh, do you? Excellent. I'm always happy to
Yes.
speak to Grass users.
Yes, we are becoming extinct, I guess.
It's a pretty old system, but I think it's really good. Yeah.
Yes, so now that this is nothing related with Google Earth Engine, but now that you mentioned that, I would like to know how to do that, because
Okay.
usually I have to loop and iterate through my basins. I do,
Yeah.
and I do that throughout R, but maybe it will be useful for me to run directly from Bash. I mean, if
It
you
would because so you can run a bash cell here operating your grass commands. And then you can have a cell down here, which is R, and you can run your R commands in here. And then you can go back to, you can basically run R inside grass and grass inside R, you know, and that's the beauty of it. And you can have Python cells too. But what I do, so what you know, so if you're used to using the grass bash script area, then what you do is you open grass. So I would open grass as a, I don't know what whenever my last one was, whether it was text. So I open grass like this in a text environment, and then I open my Jupyter notebook. But before I do that, I don't know whether I've got the right Condor environment opened at the moment. So I have to have the right Condor environment open in order to do that. But I can try. I don't know. Yeah, I have. Maybe I can. I can't remember how I set it up. Whether I can do it inside the same environment, whether I have to choose a different Condor environment. Yeah, here we go. Okay. Now, no, it's no good. Now, the reason it's no good is I still only got a Python 3 option open to me. So what I need to do is change environments before I go into grass. I'll stop that server, and before I go into grass, I can't remember the name. Condor, is it list? Is that how you do it? I can't remember whether you list environments. I think it's called grass. Yeah, there we go. Base PyCharm E Jedi, for example. I think it might be PyCharm. It's my normally it's my default environment, but because as I've been doing these tutorials, I had to reset my default environment to my base environment, and as a result of that, I can't remember which environment I use for grass. I think so. Jedi is G. Oh, maybe it's just base. I can't remember. Anyway, I have to. But what I would do, how I would do it is this: I would look for Jupyter, and then bash, and I'll show you which one I used. IPython commands. I can't. That's one. No. IPython bash commands Jupyter notebook. This is one of them, the bash kernel. It's not the no, that's not the one I use. But anyway, this is an example of a bash kernel. So if you install this, then you can just run a Jupyter notebook, and it gives you the bash kernel option here. When you're here and you want to choose a new notebook, you've got the bash option here, and that's what you do. You do that, and then you do that from inside your grass environment. Yeah. I'm not set up to show you, but I can do that. Again, I can give you that information if you like.
Okay. Yeah, very useful.
Yeah, it's very good. Any other questions? I'm going to scroll down in case I think someone's typed a message. No questions in there. Right, so look, if you haven't got any questions, I will I'll stop going on about stuff, and you know, we'll call it a day.
I have a small question because I tried to pass the local object into R, but this is a dictionary. This because for me it's quite convenient to try to do all the dates
processing in R
Yep.
instead of Python,
Yep.
but I need to pass. I mean, from the local objects, how can I generate a list with the values?
Okay. So you basically have to, as far as I'm aware, I think you have to pass objects into R as a NumPy array, I think. Right?
But also as a list.
I think just as a NumPy array, which is a list, but it's a special list, right? Now, up here, you'll see there is a somewhere along here. You see this here? You see this line here? Line 18 here. That is allowing me to import string vectors as NumPy arrays into R. So that's how I got my dates in to here. My dates are a string, a list of strings. So you just create a list of string dates, manipulate your data into a list of date strings, and in a format that R will recognize, which is I just did year, month, day. And then you just put it into an array. Just put it into a NumPy array and then pass it in.
I see. Yep. I'm gonna try.
And I think you can pretty much get anything into R that way. Because you can put strings into arrays, into NumPy arrays, I think you can put anything into R that way. Yeah, I can't see the limitations because you can convert anything into a string. I mean, even if you've got a dates, I guess is a classic example, isn't it? Really. So up here we're manipulating dates. We've done it several times. We've gone from milliseconds into this Julian date format, and then back into a date object here, and then back into a string here, and then into a NumPy array, and from the NumPy array back into a date function in R. So we've pushed them around quite a bit before they've got to their final destination.
I see.
Yeah. Any more questions? You can keep going, I don't mind. But I've got nothing more to say otherwise.
Okay, now I'm trying to deal with the Python script to make that. I guess I'm quite close to do that.
Okay. Yeah. You'll get there, for sure. Okay. Anyone else? So what I'm going to do, basically, when we'll close now, and I will make sure that I give Yvonne those scripts that she can email to you, because it seems to be a bit problematic, me pasting them into the chat group. Otherwise, I think we've certainly recorded today, so that should be available to you, assuming I click the stop button after some time. Then all that remains is for me to thank you very much for all your time, and thanks very much for all your feedback. It's been good.
Thank you.
Thank you very much.
Thank you.
Damien. No, thank you very much.
Thank you so
It's been
much.
great. And
Yeah.
I'll leave you all to disappear, but I'll just stay here and let you all go. Yvonne, I'll pass those scripts to you very shortly.
Yep. I just wanted to pop in to say one more thing as well.
Okay,
Send-
sorry. Yvonne's
Yeah.
got something to say first.
I'll be sending out a feedback form, so your feedback is really valuable to us. Tell us what we did well, what we didn't do well, so that we can improve our future courses for you and for others as well. So please fill in the feedback form that I'm going to send out. Thank you.
Yeah. Absolutely. Thanks, everyone. Okay.
So there's a question about Solophone.
Yeah.
Yes.
Yeah.
I will. Sorry, I've lost the chat area, so I'm going back to the chat area. So, what's your question?
Hello.
Hello. Yep.
Yeah, I just want to know if how is the delay time between data acquisition by satellite and the availability of this data on Google Earth Engine?
It's a good question. It seems to be sort of 5 to 7 days, something like that, I believe. It's sort of a bit less than a week, usually, I think. Yeah.
Oh, so is there any like a advanced class next month? I think you talked about in the beginning of the course.
Yes, there will be, but it's not finalized yet what the topics will be. So that course hasn't been arranged yet. But yes, there will be definitely. Yeah.
Oh, okay.
Excellent.
Yeah.
I can imagine how good should be that, because if this is excellent, I can expect.
I appreciate that, Ivan. It will probably be good because it won't be me doing it.
Yeah,
So-
I'm sure.
Wonderful.
And it'll be somebody whose Spanish is much better than mine as well. I can promise that too.
Yeah, and apart from the advanced course, we are also working to develop a machine learning one as well as a Earth Engine apps one. So
Yes.
that's in the pipeline in the next few months.
Yeah. Yeah, that'll be good. So I might be party to the content of those courses. Yeah. Possibly. Or maybe not.
I think you will be.
Okay. Right. Yeah. Okay. That's good.
Okay, if I can have one more technical question.
Please do.
I mean, you referred to this, I mean, about the data organization, because today we were using this project's Geodata Science Public, which is not searchable, of course, and is it somehow visible on the interface, or is it just?
So you're talking about the silo data
Yeah.
assets you should be looking at. I can make it visible to you by pasting you a link. You should have access to that.
Yeah, I have access, but because it's running, but you know, it's okay. So this is the sharing area. Okay.
Yeah, I mean, what you see here is not the total that's on here. This is the total that I've got links to myself that I've been using, and I believe there are lots more data sets on there. But there's an awful lot pertaining to Australia, basically. So we've got the low tide DEMs, for example, what's called the Bare Earth Mosaic, which is basically looking. It's been scouring the imagery for times when the vegetation is at its absolute lowest. So when the leaf area index is at its absolute lowest, and gives us as bare a possible mosaic of the continent. It's got a high tide version of the DEM. We've got various things on here, but they all pertain to Australia, I'm afraid. But they are all publicly available, I believe. Yes.
Okay, but yes, partly it's we are getting to the point because we were using this data even though we didn't see it. So it's just a matter of then access lists, or it's available anyway by anybody.
Oh, I see what you're saying. No, it's not. there are not access lists, but you need a link to find it.
Okay.
Yeah, that's that answer. I mean, I don't know how in the future that might change. I'm not sure whether that will be made sort of by default available on there or not.
But is it the, let's say, the setting of your catalog, or is it the feature of Google?
It's a bit of both because I have read-write access to this catalog. It's on here, but I think pretty much it's just a simple fact that because I have had links to this and I've accessed those links, then it has appeared in my list of assets like this.
Okay.
If I get a new username and sign on with that, I'm not going to get this, but I could still use the link, follow the link, and this will then appear under here. Yeah. Yeah. It's pinned there. I think I can unpin it by clicking this button. You see, I think if I hit this button here, it will disappear, and I won't get it again until I follow the link again. Oh, I don't want to click it.
Okay. Okay. Thanks.
Okay. I don't think there are any other questions coming. So I shall leave you all in peace. Ivan, if you want more help, with anything, it's absolutely happy to help. Please feel free to send me an email or hook up or whatever you like.
You can be sure about that.
Okay, that's good.
Yeah, me too, Damien.
Yeah, absolutely. Please do. Please do.
Thank you. Are you in the mailing list?
I'm on the very first slide. My email address is there. I'll try and find it. Just give me a second.
Well, we kind of talked about having.
We'll look for it first. You think I'd know it, wouldn't you? My slides.
I think you're there. So, Damien, right?
Yeah, I've got it. I found it. Look here. It's right here. There. There we go.
Okay.
Sorry about that.
Damien. Yeah, Damien. Okay, you're here in the mailing list. Okay. Excellent.
Yep, and if you guys also want to send your questions to the support email, that's a ticketed system. So make sure that if Damien is on holiday or something, someone else in the team will pick it up and respond to you.
Just send it to both.
Thank you.
It's fine.
Yep.
You might get an answer.
Excellent.
Okay. All right, I'm going to go. I'm going to hit the red button, which means stop recording.
Bye.
Okay,
Thank
so
you,
thanks.
everyone. Bye.
Thank you very much. Thanks for all your feedback. It's been